Okay, this video is about a little bit more about transforming functions. We already know how to shift a graph, both horizontally and vertically. We know how to move it up and down and right and left according to the function, and we know how to stretch vertically. So in this lesson, we're going to see how to stretch horizontally. Can you stretch it going right and left instead? So we're going to take a look at that in the graphing calculator. So let me pull up my graphing calculator. And we've got this function right here. Here's the original of it. And so I'm going to go ahead and put that in here. So I need to I need to open up the graph on my graphing calculator. So here's the original function right here. So let's review what kinds of things happen when we multiply out in front that function. So let's give that a try. I'm going to open my entry line and let's put in for function 2, I'm going to put in a stretch. So if I put in 2 times the function x, remember you use the variable, and I've got f of x in there, so I'm going to choose that, and of x, and graph that one. So as you can see, the original one got stretched. It's 2 times more stretched than the other one. Okay, so now let's take a look and remember what happens when we multiply by a smaller number than 1, like a fraction. It's sort of like dividing. So let's take a look at that. Get my entry line. If your entry line ever disappears, you can do this on your calculator using menu. Okay, so how about we do 1/2 the function f of x. So there's f of 1 and put in x, and if I graph that, there's the new one. It is squashed. It is shorter than the original function. It was compressed. Okay, so what I need you to do in your notes is summarize what does putting a number in front of a function do. If you multiply it by a number greater than 1, what happens? If you multiply out in front by a number less than 1, a fractional number, then what happens? Okay, so now we're going to move on to the next one. We're going to take a look at what happens when you put the input in the parentheses. Okay, what we did in the previous one, we took our value, call it k, and we put it out in front. We started with k of 2 and that stretched it. Then we did a k of 1/2 and that compressed it. What happens if we put the value k in here next to the x instead? So now let's take a look at that. Let's bring back the calculator and see what happens. So I'm going to go ahead and erase the second one, get rid of the second one and the third one, and start with the fourth one. Okay, so this time I want to choose my function f of x, f of 1, and then I want to do my number, my k value, let's use 2, inside the parentheses, acting on the x, and see what happens. So what happened? In your notes, describe what happened. This pink curve right here, it's now more narrow side to side than the original blue. So what happened when I multiplied by 2 inside the parentheses with the x? Well, I would call it compressing, but instead of compressing down and up, it compressed side to side. So what is your guess? What do you think is going to happen if I now put a fraction in there? What's going to happen if I put, let's say, 1/4 in with the x? So let's give that a try. I'm going to find my entry line again and put function 1. Oops. And I'm going to put 1/4, 1 divided by 4 of x, and graph that. Ah, much, much wider, 4 times wider stretch to the side to side. So let's summarize this a little bit. Wouldn't you say that a k in front of a function that stretches and compresses vertically up and down this way? And if we do the k value inside with the x, that stretches and compresses horizontally this way. And it's backwards of what this one does. If, in this case, if k is greater than 1, we get a stretch. If k is less than 1, we get compression. Well, when we do this one, it seems backwards of that. If k is greater than 1, we get a compression. And if k is less than 1, we get a stretch horizontally. All right, that's the end of that. Just get that into your notes, and that's it. See you on Monday.